In our previous videos, we have learned about photoreduction of carbonyl compounds. Today, we shall learn about hydrogen abstraction reactions of carbonyl compounds. These are also very similar to photoreduction of carbonyl compounds, except that photoreduction of carbonyl compounds are intermolecular hydrogen abstraction reactions. But hydrogen abstraction reactions consist of intramolecular hydrogen abstraction reactions also. So let's see hydrogen abstraction reactions of carbonyl compounds. Upon irradiation by UV light, hydrogen abstraction occurs in carbonyl compounds. Hydrogen abstraction is of two types. One is intermolecular hydrogen abstraction. Second is intramolecular hydrogen abstraction. Intermolecular hydrogen abstraction means hydrogen abstraction occurs between two different molecules. So, intermolecular means abstraction between two different molecules, whereas intramolecular hydrogen abstraction means hydrogen abstraction occurs within the same molecule. First of all, let's consider intermolecular hydrogen abstraction reactions of carbonyl compounds. As we have learnt previously, hydrogen abstraction reactions which occur between two different molecules are called intermolecular hydrogen abstraction reactions. Here, aromatic carbonyl compounds in triplet state will abstract H atom from hydrogen donors or organic solvents which are present in ground state. These hydrogen donors are methyl alcohol, isopropyl alcohol, benzahydrol, toluene, etc. About these we have already learnt. These reactions are also called photoreduction reactions of carbonyl compounds. We have learned this in our previous lecture, but here we are considering this because we are talking about hydrogen abstraction reactions. Hydrogen abstraction reactions are two types, intermolecular and intramolecular. So before we start intramolecular hydrogen abstraction reactions, we have to go through intermolecular hydrogen abstraction reactions. So let's see the example of benzophenone in methanol or methyl alcohol. Here benzophenone is the organic carbonyl compound. Methanol is the hydrogen donor or organic solvent. So as all we know, benzophenone is nothing but PH C double bond O. It is present in ground state. When it is irradiated by UV light of 345 nanometers, it undergoes N to pi star excitation and enters singlet state. From singlet state, it enters triplet state through intersystem crossing. In the triplet state, the pi bond between carbon and oxygen cleaves homolytically to give us a biradical, which is also called alkoxy radical, that is PH C radical and O radical. This is called alkoxy radical or biradical. Here methanol is present in S0, that is ground state. Methanol is nothing but CH3OH. A bond between hydrogen and carbon cleaves homolytically. releasing this hydrogen. This hydrogen atom is abstracted by oxygen atom of the alkoxy radical, giving us two new radicals. One is benzhydral radical, another is hydroxymethyl radical. Benzhydral radical is PH-PHCOH radical, and hydroxymethyl radical is CH2OH radical. These are the two new radicals we get here. Now let's see the remaining procedure. These two new radicals, that are benzhydral radical and hydroxymethyl radical, will give 5 products. Let's see one by one. First product, 2 benzhydral radicals will dimerize or combine to give benzophenol. This benzophenol is the major product. So this is benzhydral radical, PH-PH COH radical, and this is another benzhydral radical, PH-PH COH radical. This radical and this radical will join together to form a new bond, as a result of which we get PH-PH COH, a new bond between these two carbon atoms, and PH-PH COH. This is benzophenol. This is the major product of the reaction. Now the second reaction is benzhydral radical will abstract H atom from hydroxymethyl radical, and it will form methanol, okay, and methanal, that is formaldehyde. Let's see the reaction. PH-PH COH radical will abstract a hydrogen atom from CH2OH. This hydrogen atom, connected to the oxygen atom, is abstracted by this benzhydral radical, as a result of which we get PH-PH COH and H. This is nothing but diphenyl methanol. Methanol because alcohol group OH is present here. Now this CH2OH has lost a hydrogen atom, so it becomes CH2C double bond O, which is nothing but methanol or formaldehyde. So here this benzhydral radical has extracted a hydrogen, so this is the reductive product, and this hydroxymethyl radical has lost a hydrogen, so formaldehyde is the oxidative product. So this diphenyl methanol, this is the diphenyl methanol. See, to the carbon atom, 2 phenyl groups are attached and a OH group is attached, so it is called diphenyl methanol. This is a reductive product, whereas formaldehyde is an oxidative product. Up to now, this product A, that is benzophenol, product B, that is diphenyl methanol, and C, formaldehyde, these are the main products of this reaction. We will get some minor products also. Let's see the minor products. So this is the third reaction. benzhydral radical and hydroxymethyl radical will join to form 1,1-diphenyl 1,2-ethane diol. Let us see the reaction. This is the benzhydral radical. PH, PH, COH radical. Hydroxymethyl radical. Hydroxymethyl radical is this. CH2OH radical. This radical and this radical will join together to form a new bond here. As a result of which we get PH, PH, OH and CH2OH radical. These two radicals will join to form a new bond here. So as a result, this carbon is 1, this carbon is 2. So we get 1, 1, 2 ones because 2 pHs are there attached to carbon atom. So 1,1-diphenyl, 1,2-ethane. This is C and C is called ethane. So 1,2-ethane diol because OH groups are present in first carbon and second carbon, we call 1,2-ethane diol. So this is a minor product. Another minor product is 2 hydroxy-methyl radicals will join to form 1,2-ethane diol. This is hydroxy-methyl radical, that is CH2OH radical. Will combine with another hydroxy-methyl radical, CH2OH radical. These two radicals will join to form a new bond. This is the first carbon and this is the second carbon. So as a result, we will get 1,2-ethane diol. Diol because two OH groups are attached to first carbon and second carbon. Since two carbon atoms are present, it is called ethane. So this is 1,2-ethane diol. Let us see another example. So we'll see the example of phenyl cyclohexanone in isopropyl alcohol. This is the phenyl group attached to a cyclohexanone. So this is called cyclohexanone, which is present in ground state. Upon irradiation by UV light of 345 nanometers range, it gets excited to N to pi star transition and enters singlet excited state. From singlet excited state through intersystem crossing, it enters triplet excited state. This is the triplet excited state. In the triplet excited state, the pi bond between carbon and oxygen cleaves homolytically, forming an alkoxy radical or biradical. See this pH and this hexane ring and oxygen. There is a radical here on the oxygen and the carbon. So it is a biradical. In the meanwhile, the isopropyl alcohol, that is CH3CHOH, the bond between carbon and hydrogen cleaves homolytically. This hydrogen atom is abstracted by the oxygen atom of the alkoxy radical, as a result of which we get two new radicals. One is phenyl cyclohexanol radical. Another is hydroxy isopropyl radical. This is hydroxy group. So it is called hydroxy isopropyl radical. These two new radicals, that is phenyl cyclohexanol radical and hydroxy isopropyl radical, will give new 5 products. Let's see the first product. 2 phenyl cyclohexanol radicals will dimerize or combine to give diphenyl dihexane 1,2-diol. Let's see the reaction. This is phenyl cyclohexanol radical. This is phenyl group. This is cyclohexanol radical. Will combine with another phenyl cyclohexanol radical. This is the phenyl group. This is cyclohexanol, nol because OH is present. These two radicals will join together to form between these two carbon atoms. So this is the first carbon atom, this is the second carbon atom. So it is called diphenyl. 2 phenyl groups are present. Dicyclohexanane. 2 cyclohexanenes are present. Here we are not saying hexanol because we will be mentioning diol here. 1,2-diol. That is, OH groups are present on the first carbon and the second carbon. So it is called 1,2-diol. This is nothing but a pinacol. This is also a pinacol. Any compound having OH groups on adjacent carbons are called pinacols. We know that. So this is the major product. That is diphenyl dicyclohexanane 1,2-diol. Major product. Okay. Second reaction. Phenyl cyclohexanol radical will abstract H atom from hydroxyisopropyl radical. This is phenyl cyclohexanol radical. This is hydroxyisopropyl radical. There is a radical here, radical here. This phenyl cyclohexanol radical will abstract hydrogen atom from the OH group of the hydroxyisopropyl radical, as a result of which it will get saturated by addition of hydrogen atom. So it becomes phenyl cyclohexanol, that is an alcohol. And this hydroxyisopropyl radical loses a hydrogen atom, so it forms a double bond with carbon atom. So it becomes CH3 C double bond O, which is nothing but acetone. This is an oxidative product, whereas phenyl cyclohexanol is a reductive product because it is receiving a hydrogen atom. So phenyl cyclohexanol is a reductive product, whereas acetone is the oxidative product. Now let us see the other reaction. These two are these compounds formed here. A, that is diphenyl dicyclohexanane 1,2-diol, and phenyl cyclohexanol and acetone are the major products or main products. These three are the main products of these. This is the major product, that is diphenyl dicyclohexane 1,2-diol. Let us see the remaining minor reactions and formation of minor products. So as we have said, A, B, C are main products. Let's see the minor products. So the third reaction, phenyl cyclohexanol radical and hydroxy isopropyl radical will join to form phenyl cyclohexane 2,2-dimethyl 1,2-ethane-diol. What does it mean? Let's see. This is phenyl cyclohexanol radical. We know that. This is hydroxy isopropyl radical. This radical and this radical will join to form a new bond between these two carbon atoms, as a result of which we get a bond between carbon 1 of phenyl cyclohexanol radical and hydroxy isopropyl radical carbon. So we get phenyl cyclohexane. Here also we are saying cyclohexane, not cyclohexanol, because we will be mentioning the hydroxyl groups later. So we say phenyl cyclohexanane 2,2-dimethyl. That means on the second carbon 2 methyl groups are present. So phenyl cyclohexane 2,2-dimethyl 1,2-ethane-diol. 1,2 means first carbon and the second carbon OH groups are present. So it is a diol. 2 carbon atoms, so it is ethane. So this is phenyl cyclohexanane 2,2-dimethyl 1,2-ethane-diol. Now the fourth reaction. 2 hydroxy isopropyl radicals will join to form 1,2-tetramethyl 1,2-ethane-diol. See, let's see the reaction. This is hydroxy isopropyl radical, that is CH3CH3COH radical will join with another CH3CH3OH radical. These two radicals will join together to form a new bond between them, as a result of which we get a bond between first carbon and second carbon. There are 4 methyl groups, 2 on first carbon, 2 on second carbon. So it is called 1,2-tetramethyl 1,2-ethane, 2 carbons, so ethane diol, because 2 OH groups are present on first carbon 1 OH group, second carbon 1 OH group. So it is 1,2-ethane diol. So this is 1,2-tetramethyl, 4 methyl groups are there on the altogether on the first carbon and the second carbon. So this is 1,2-tetramethyl and 1,2-ethane diol, because 2 hydroxyl groups are present on first one on each on first carbon and second carbon. This is the hydrogen abstraction reactions of intermolecular hydrogen abstraction reactions of carbonyl compounds. As all we know, these reactions will occur only in aromatic ketones, which should be present in triplet state, and the hydrogen donor or organic solvent should be present in ground state. So these are intermolecular hydrogen abstraction reactions of carbonyl compounds. In our next lecture, we shall consider the intramolecular hydrogen abstraction reactions of carbonyl compounds. Thank you very much. Please like, share and subscribe.